as per the lecture plan shared with you. So let's start our first session of this GAN course now.
Okay, welcome back. So today is the first section of our courses, which is about the thermochemical conversion of biomass to biofuel, bioenergy and value-added products. So as usual, so I would like to really express my very great appreciation to Ranjit for organizing this GAN program. So with this, we all can learn about this thermochemical conversion, and also I'm very great to be here to share a little bit of my knowledge about the biomass energy, about the thermochemical conversion to all of you. So before I begin, maybe I would like to briefly introduce about myself. So I'm from Malaysia. So how many of you know Malaysia or don't know Malaysia? Do you know Malaysia? Where is Malaysia located? Huh? You know or not? Where is Malaysia? Anyone don't know Malaysia? Malaysia is located in the Southeast Asia. We just neighboring with Singapore. I think most of you are more familiar with Singapore, right? So we just neighboring with the Singapore country in Singapore. So this is where I come from. So here is a little bit about myself. I'm Malaysian. I come from the Sunway University. So I just returned back to Malaysia last year. Not last year, because this is 2025 already. In 2023, I just returned back to Malaysia. And now currently I associate with the Sunway University. And later on I will briefly introduce what is the Sunway University. Sunway University is one of the non-for-profit private universities in Malaysia. Later I will tell you. So prior about that, I'm have 2 years experience in Taiwan, in Wintech National University. Then 2 years in the Australia University of Technology, Sydney. And before that, I worked in University of Malaya, Malaysia for more than 7 years. So maybe I can briefly go through to my profile. So what I'm doing here. Here. So what I'm doing is my focus area is more on the biofuel and bioenergy, energy and fuel. So with align with the SDG 6, 7, 12 and 13. With the SDG 6 is about what? About the clean water, about the environmental clean water. And SDG 7 is what? The green energy, green energy. And SDG 12 is about what? Sustainable products. And SDG 13 is climate action. So which closely related to these courses. So these courses also will take or in line with the SDG 6, 7, 12 and 13. Which we want to have the sustainable clean water to combat with the climate action with the sustainable product. Yes, we can produce anything, everything. So but how about what is the sustainability of our production? That means what? So how about the waste? How are you going to manage the waste? So how are you going to make sure the overall production cycle is clean? So many people agree that, oh, I can produce the green energy. But, for example, the solar energy. Solar is a totally green, during the consumptions. How about their productions? They are using the what? The silicon, Zika, and after the lifetime of the solar panels, after 25 years, how about the waste? Yeah, that's the thing. We need to make sure the overall life cycle are sustainable. We not about the totally clean, because it's impossible to be totally clean. So how to be sustainable? Sustainable in terms of what? In terms of the energy and in terms of the waste. How we going to reutilize the waste materials? Yeah, this is the sustainability. We need to see the overall life cycle, not only the particular the consumption section only, or maybe the particular production section only. We need to look at the overall life cycle analysis. So this is what I'm doing. So this is about my research areas. So basically what I'm doing is closely related to energy and fuel, green and sustainable energy and fuel. Particular technology that we are using is the thermochemical conversions. So later on I will tell you step by step what is the thermochemical conversion. There are many different various type of the technology of the thermochemical conversion. Thermodynamical conversion is not the one new technology, but how we going to upgrade it or make it sustainable. That is the key point. Key areas that we need to look at it. And sustainability and environment. Environmental sustainability. And not only we want to produce the green energy, but we need to make sure the environmental sustainability. I guess most of you are from the environmental background, right? If not mistaken, I'm not sure. Later I ask you. So in these courses, we are focusing more on the biomass energy or waste management. How we going to utilize the waste, and also the techno-economic analysis. Because what this world is very realistic. The investor, what they look at for the investor, dollar and cents, right now, dollar and cents. We need to make sure, even though our process is totally clean, we need to make sure this is the financially sustainability as well. Not only energy environmental, but also the financially sustainability. We need to look at the overall the techno-economic analysis, overall finance balance that the investor can gain some profit out of that. So how to make it? Yeah, it's heavy because when we look at the overall the life cycle analysis, also the circular economy analysis, it is possible. It is possible. So this is bit about myself. So because currently I'm also the adjunct professor in the University Technology Sydney, which previously I told you that I spent 2 years there in the University of Technology Sydney. Currently I still the adjunct professor there. So anyone of you interested to further study in Malaysia or in Australia, you can feel free to contact me because I still can recruit a student both in Malaysia and in Australia. Yeah, supervising the basically the PhD students. Because why PhD students? Because I think same in anywhere, including I think India. For the fully funded scholarship, basically I only awarded to the PhD scholar. The qualified PhD scholar, not every scholar, the qualified PhD scholar for the fully funded PhD program. So master program, yeah, you are welcome to study in Istanbul and UBS as well, but there are no any fully scholarship for the master student. Basically, they don't have. So it's really depend on the project. So either your supervisors provide you with some money stipends or maybe tuition fee waivers, but master study they are very less scholarship for that. So what else? Okay, so this is my research area. I already inform you. So this is my email contact. You all feel free to contact me if you have any questions about the courses, about the thermochemical conversion and about the biomass energy. Yeah, feel free to contact me and to have the discussion. So this is about the Malaysia. I think you know already. So this is about the Sunway University. Sunway University is located in the Selangor, Malaysia. Selangor, Malaysia is neighboring with the Kuala Lumpur, which is in our kilometers. It's only 20 to 25 kilometers from the city centers. I mean the Kuala Lumpur city centers. So actually, the Sunway City is one of the sustainable city. Sustainable city. Why I say the sustainable city? Inside the Sunway cities, we have what? Hospitals. We have the education from the primary until the university. Then we have the amusement park. We have the theme park there, and we have the hotel, restaurant, shopping mall. So basically, Sunway City is the sustainable city. Here is the canopy walk. So it's overhead cover canopy walk, which you can walk around the Sunway City, connected to the hospital, to the shopping mall, to the amusement park. So all of you are welcome to visit the Sunway City. So the university is located here. This is the Sunway University. That side is the shopping mall and hotel. Hotel there. So in the opposite of the Sunway City, we have the Monash University. Have you heard about the Monash University from Australia? Yeah, the Malaysia campus is in the opposite of the Sunway University. So we also have our own electric bus surrounding with the Sunway City, because we want to make it the Sunway City is totally sustainable and green. The pavement around the Sunway City, it can absorb the water. So during the rainy time, it can absorb the water and correct the waters. Yeah. So make it totally sustainable. Then here the solar panels. We have the solar panel. So this is a little bit about the Sunway University. I have the very short video clips. Perhaps I can show you the video clips.
Sunway University is a leading research-intensive and entrepreneurial university in Malaysia, tasked with solving some of the world's biggest global challenges. In just over 10 years since its foundation, the university has risen rapidly to be ranked within the top 2% of the universities in the world. Despite its young age, Sunway University is widely acknowledged for its outstanding achievements in sustainability, teaching, facilities, inclusiveness, internationalization, and employability. Sunway University holds the prestigious Premier Digital Technology University status in Malaysia, leading in digital technology and research. As a not-for-profit institution through the Jeffrey Chia Foundation, the university's financial resources are dedicated solely to our academic mission and to supporting many scholars, educational programs, and research activities. Most universities have a campus. Only Sunway University has its very own city. Located in the heart of Sunway City, Malaysia, an award-winning integrated, smart and sustainable model city with world-class amenities including one of Southeast Asia's largest retail, hospitality and lifestyle hubs, along with a world-class private hospital. Conveniently located in Greater Kuala Lumpur, Sunway City offers easy access to downtown Kuala Lumpur, as well as the nation's international gateway, the Kuala Lumpur International Airport. The modern purpose-built Sunway campus houses state-of-the-art lecture theatres and classrooms, extensive research laboratories, creative studio facilities, and recreational sporting facilities, including a FIFA-accredited football field. A wide array of unique study areas enhances the student learning experience. The Tun Hussein on Sunway Libraries is rightly proud of its extensive physical, digital and online resources as one of the largest university libraries in Malaysia. This includes a unique collection of books and publications from Harvard University. Sunway University is heavily committed to the United Nations Sustainable Development Goals, as it actively nurtures a holistic approach to education. A planetary health mindset ensures our future leaders are globally aware. Sunway University has become synonymous with proactively highlighting economic, social, and global issues, and nurturing solutions to these challenges through the establishment of the Jeffrey Sachs Center for Sustainable Development, the foremost center in Asia undertaking research and education related to the Sustainable Development Goals, and the Sunway Center for Planetary Health, which focuses on bringing interdisciplinary approaches to mitigating future risks posed by pandemics and other worldwide health challenges. In 2019, Sunway University became the home to the UN Sustainable Development Solutions Network for the Asia region, alongside Paris representing Europe and New York for the Americas, meriting the university with its growing reputation as a campus with a conscience. Established academic schools form the key pillars of Sunway University, with programs in the disciplines of the arts, sciences, mathematics, engineering, technology, health, communication, hospitality, and business. Students experience employment-focused academic programs from diplomas to doctoral degrees. Fully online degrees and micro-credentials are designed for those seeking upskilling career advancement opportunities. We understand lifelong learning. The university's innovation labs help students develop their own business ideas with mentoring, accelerated programs, and comprehensive venture building support. Research centers and institutes actively work on cutting-edge developments such as aging, well-being, cancer therapies, data science, energy technologies, nanomaterials, and vaccines. Pioneered by outstanding research professors, many of whom are recognized as the top 2% in the world in their respective fields. Sunway University enjoys collaborative research and academic partnerships with the world's leading institutions, such as the universities of Oxford and Cambridge in the UK, Harvard and MIT in the United States, and many others globally. The progressive international reputation of the institution has seen Sunway University at Sunway City become an international beacon of inspiration and learning for thousands of students from all across the globe. With nearly 100 nationalities represented on campus, it is a campus community that is diverse, inclusive, and welcoming. As one of the top universities in the region, we have ambitious plans to expand rapidly in many key areas of research, teaching, and learning with our international partners across the globe. Paving the way of the future is the exciting new home of the Sunway University Business School and the School of Arts, offering stunning lake views and an extensive performing arts sector destined to become the vibrant cultural hub of Sunway City and Malaysia. Sunway University at Sunway City, Malaysia. Truly a class above.
Yeah. So this is a little bit about the Sunway University. A little bit about the Sunway University. So currently we have around 10,000 students with 88 academic programs. So most of our academic programs have related with the Lancaster University. So at the end of the study, you will get two certificates. One is the Sunway University certificate, another one is the Lancaster certificate. So what I want to highlight here is even though we are the private universities, we are not for profit. Not for profit. So currently we have total 7 schools, which we have the business, arts, engineering, and technology, which come from the engineering technologies. So this is our laboratory buildings. So we have the chemistry lab, the electronic lab, the instrument lab. We have the GC, DGA, and also the power lab, and also the physics labs. So this is the facility that we have. So we have a few research centers, fluid mechanics labs, and the thermodynamic labs. Yeah. So this is about myself and also my university. So similarly, I want to know about yourself because I need to know where you all come from so that I can cater and design the program for you and what is your expectation and concern about these courses. So maybe you can prepare the short presentations about yourself. You don't necessarily present, you just prepare, then just send it to me, email to me so that I can know your background, so your name and your photo so that I can recognize who are you and where you come from and current aspirations currently related with the universities or the industries. So what's your experience and the current position? Current position is means what? whether you are the master scholars or the PhD scholars, or you are postdoc, or maybe you are the professors, or you are the industry players. So basically, most of you are come from the master students or PhD students or what? How many of you are PhD scholars? Oh, most of you are PhD scholars. Half, I think half. Master scholar? Oh, another half the master scholar. Okay, master and PhD. Okay. So, anyone of you come from the industry? Oh, you come from industry also. Okay.
Few industry participants online.
Oh, few participants online. Okay. Okay, basically here is a master and PhD, then a few from the industry. So any academic staff here? Oh, one academic staff. Oh, okay. From which departments?
Chemistry. Chemistry department.
Chemistry department. Doing the biomass energy. Or what? No, not really. How about yours? From chemistry as well? No.
Agriculture.
Oh, agriculture. Oh, so you want to settle or maybe handling the agricultural waste. How about you?
Chemistry.
Chemistry, chemistry.
So chemical engineering.
Chemical engineering, chemical engineering. So what is your major? I mean the expertise.
So my PhD work is on this topic.
Oh, on this topic. So you are very familiar with this topic. Okay, yeah. So maybe I can do the prepare the short presentation. So about the PhD and master scholar. So most of you are from the environmental engineering, chemical engineering. How many of you are from the chemical engineering? Chemical engineering. Environmental engineering? Oh, basically environmental engineering. Chemical environmental engineering. So you prepare. So what is your expectation for about these courses? What you plan to learn about these courses? About what? So that I know. Any of you? Okay, yeah, please.
In India, there are a lot of STP plants, sewage treatment plants.
Yeah, see.
And they have some technology for hygienization to remove pathogens, but they don't have any proper mechanism to sell it commercially, to make a value-added product out of it, like a fertilizer or anything like that, and officially sell it, licensed product. It's not there. We are considering, we have few municipalities that are producing from tens of tons to hundreds of tons a day of dry sludge.
Correct.
And we want to figure out if we can commercially make anything out of it.
Correct.
Solid, liquid.
Yeah, correct. So this is one of the concern as well, you know. So there are no any very close connections or the correlations between the industry and also the academics. So among the academics, our focus are basically very specific. So currently, not like maybe 20 years or 30 years back, we must have a very specific disciplines. Now you need to interdiscipline, which connecting each and others, you know, so that we know what other people need, so that we can achieve one goal, which is the circular economy, all the materials or waste or the resources, you know, not only in a single discipline. So this is one of the, just now you mentioned. Yeah. What are your expectations?
Actually, I'm working in biomass.
Biomass, yeah.
Yes. So, how can biomass be converted into bioplastic? Although many of the work has already been done, but particularly in India, how to convert the biomass to bioplastic, and then how can it can be used in various products and can be industrialized. So this is my focus.
Yeah, fully agree. Because this is another issue facing by currently in the industry as well, and also the academic world. We have many technology. Many technology are already mature, but how we going to make it commercialized or make it the real product that can accept it with the end user? How we going to attract the investor to invest it? For example, you talk about the bioplastic. We have the technology for the bioplastic to convert the biomass into the bioplastics. But how to make it economical sustainability? That is the one thing. Because why? The fossil plastics, the cost of the fossil plastics is very low. Correct not? But it will create a very harmful emissions. So how we need to take the balance between these two? This is one of the challenges that facing by the current world. Yeah, that's the thing. So anyone, the last one, what's your expectation? Anyone about this courses? Anyone want to share?
There's one more.
Yeah.
So my friend is running a pyrolysis unit, plastic pyrolysis unit.
Plastic pyrolysis, yes.
And in India there are probably hundreds of pyrolysis units that are using old reactors.
Old reactors, yeah, old reactor. You mentioned the old reactor. What do you mean by old reactor? Reactors but powered by the what? Powered by electrics or powered by what?
Dirty fuel, like coal or.
Oh, powered by the coal. Okay, then.
They convert plastic into pyrolysis oil, but they use dirty fuel
Understand.
to run the reactor.
Understand.
So that is also one issue.
Yeah, I have this experience. What we are doing now. Yeah, you can sit down. Yeah, no worry. So what we are doing now, also helping one industry in Malaysia. It's called the Eco Power. You can go to check the industry Eco Power. We are converting the waste tire, you know, the tire, the wheel, the waste wheel, into the like the bio oil. At the same time, we recover the biogas to the burner. So we don't need to use the coal to power the burner. So we run 24 hours as long as the pyrolysis is started. That one is we run at around 500 to 600 degrees C. Then we can able to get our biofuel. Our biofuel, bio oil, not biofuel yet. Bio oil, the bio oil. The bio oil that we produce can sell at around 1 ringgit per liter. Okay, maybe you have no concept why is 1 ringgit per liter. 1 ringgit because in Malaysia the fuel price, the diesel fuel is around 2.1 ringgit, 2.1 ringgit per liter. But the bio oil price can sell at around maybe 1 ringgit. 1 ringgit is around maybe 20 cents, 20 USD, 20 cents USD per liters. However, after we process it to convert it into the biofuel, we can sell it around double the price, maybe the 40 USD 90 cents per liter. So at the same time, they are use less electricity because initially the burner is powered by the electricity to make it around 500 to 600 degrees C. But after the production is stable, you can produce the biogas. The biogas can send into the burner. This is the pyrolysis reactor that we design. Send it to the burner. Then the biogas is enough and sufficient to power the burner. That is the thing. But we need to run at 24 hours because one is stopped, the biogas is stopped. But the second phase, what we want to do because the biogas that produced sent into the burner has more than its capacity. For example, we maybe need maybe around 80% of the biogas only, but we couldn't correct it because after we correct it, the overall cost is much more higher compared to business conservation. So that's why the second step of the plan, what we plan to do is the biogas, the extra biogas, we can power the another generator or the burner to produce the electricity directly to power up other appliances. Because for the storage, not feasible. Not feasible is what? Technology is feasible, not economical feasible. And also the storage, it takes up a lot of space, but it's not feasible. So that's why we need to think, what is the technology? How we going to embed other technology into the system. For example, you see, we just look at the pyrolysis system. Pyrolysis system alone is relatively simple. Then how we going to use the storage system? And also maybe another burner system or generator system, so that we don't need to store it. We can consume it directly. Then the power, the electricity produced can be power the other appliances within the country. Because in Malaysia, we have the limitation that we cannot sell the electricity. I think most of the countries say right now we have the one authority selling the electricity. We are unable, so we cannot sell to our neighboring plant, but we can consume it back in our own country. Yeah, this is what we can do.
In India, the energy prices are really low. So
similar in Malaysia, very low. Malaysia is a oil production country. Our fuel price It's even lower. If you see our fuel pipe, I would be surprised. Only cost two ringgit. 2 ringgit is I think divided by 4.2 less than 50 cents USD per liter. Diesel. I don't know about idea how much.
44 rupees.
120.
USD? How about USD?
50 cents is 44 rupees.
Oh, double. You see, we are even lower. Then they also make it cheaper.
The energy price is 5 to 6 rupees.
The electricity.
Electricity is 5 to 6 rupees per unit.
5
It's
to 6
like
rupees.
0.5 cents.
0.5 cents in Malaysia. For the residence unit is the around less than 0.5 cents per kilowatt hours. I mean for the residence. Yeah. So Malaysia has relatively low fuel and electricity price, So still can make it, with the proper planning and technology. How we going to embed this available technology? We don't need to build the new technology. So you see, for those studying the master or PhD, we thought that we need to find some novelty, correct? The novelty is creating something new. Yes, it is very good and great if you can creating something new, something relative, something new is very good. But the novelty and the significance is how we going to using the current resources of current technology, how to embed the current technology to create something that different, can make something that can make the improvement. Imagine if you can improve the energy efficiency, for example, just by 5%, you don't need to create something new. Improve the energy efficiency by just 5%. 5% that means what? The overall 5% of the energy consumption can be reduced. Then the 5% of the emission can be reduced as well, correct not? 5%, imagine the whole India, how many, what is the amount already? So, to create something totally new is very great, yes, no doubt. But to have the innovative and innovation is relatively good as well. How to utilize the current technology that we have a lot of current technology, we have a lot of the new invention things already. So how we going to utilize it? For example, now because one of the topics is very hot is what the fuel cell. You know the fuel cell, hydrogen fuel cell, right now. You know the hydrogen fuel cell. How many years already? How many years? The fuel cell technology. You know what the fuel cell?
20-30 years for hydrogen fuel cell.
No. Fuel cell is 20-30 years. Recently, it just become popular. This 20 and 30 years. The fuel cell technology. Fuel cell, you know what the fuel cell? Fuel cell. Electrolysis, H2O. Become what? Right now, this one. Just the electrolysis to produce the hydrogen. You got the hydrogen, right? This one, electrolysis. During, I don't know, during high school, we have conduct the experiment, right? Correct now. During high school, correct now. So this technology already more than 200 years. We already have this thing. Already, someone, Sir Henry, already invented this technology. But until today, it just become popular. Why? Because maybe some people think that are not economical feasible. This topic is not important, so that's why they didn't use it. We have the technology already. How are we going to packaging it into the one package, feasible package? That is something that we need to think. So to invent something better new or do or whatever the fundamental research. Yes, fundamental research is relatively important. We are the engineers. We are the engineers. We need to invent some product from the fundamental knowledge. So for those want to invent or investigate on this fundamental research also relatively good. I didn't say that you invent something new is not good. But as an engineer, how we going to utilize the current resources that are available? Yeah, this is what I want to stress here. This one, the fuel cell. The fuel cell is based on this one only. It's only electrolysis. Inverse electrolysis. That's it. This one 200 years already, more than 200 years. Yep. So yeah, maybe I finally prepare the short presentation. Maybe you can send me by maybe tonight. so that I can know what your expectation, what's your background, so that I can design and cater my lectures to be more in line with what your expectations. So any questions so far? Any questions? If not, I would like to discuss a little bit about the course overview. I think most of you have you already have the brochures about this courses. This course is about the few keywords. Because what I plan is what all of you can bring back little bit, just a little bit, little bit knowledge. I don't expect you to learn a lot of things. Yes, you can learn as much as possible. At least bring back something. For example, I give you a few keywords about my courses. First, about the biomass energy. So those doing the biomass energy, or those don't know what the biomass energy, to understand what is the biomass energy. That is the first thing. So for the biomass energy conversion, there are many techniques. So the technique that I would like to discuss here is the thermochemical conversion. We have the biological conversion or whatever. So the technique that I'm focusing here is more on the thermochemical conversion. Thermochemical conversion. This is the second keyword. Third thing, the main product that I focus more is about the biofuel and bioenergy. About the biofuel and bioenergy. This is the third keyword that I want to highlight for this course. The last one. So the overall life cycle analysis and also the emission produced. We need to know after we create something, some new technology, some new process. We need to see the overall the life cycle assessment. How much emission can be produced from the very beginning until the what? Until the end, until the consumption. From the very beginning, from the production until the consumption. What is the overall life cycle assessment? What is the total emission that can produce for the overall cycle? Not only the, for example, the consumption part, or not only the production part. For example, I use the hydrogen fuel cell. For the hydrogen fuel cell, during the consumption, the total emission can say 0. 0, correct not? So if consumption, it means it's a reverse process. Reverse process, that means what? We have the hydrogen energy plus the oxygen. Where the oxygen come from? Air. Our air has more than 20% of the hydrogen. Then the what? The only product is what? The water. You see the overall process is totally clean, right? Not? If we just look at the consumption of the fuel cell generator, is totally clean. But the question comes, how are you going to get the sustainable hydrogens? That's the thing. And how are you going to store the hydrogen? That's another issue. The third thing, how are you going to transport the hydrogen? That's the third thing. Fourth thing, how do you ensure the safety of the storage of the safety of the hydrogens? That's another thing that you need to consider. And by look at the condenser, it's totally clean. Similar to the example that I showed you before. The solar panels, the solar energy, solar power energy. The solar energy is totally what? Green, correct not? During the consumption, correct not? Because we just need what? Sunlight. And can produce what? Electricity or the hot water directly, correct not? But after the end of the lifetime of the solar panel, then how are we going to handle the waste materials? Yeah, that's the thing. So there are a few keywords, and also including I have introduced you with some of the advanced technique, how we going to embed the microwave and ultrasonic cations in the process, and also using the catalyst to enhance the process. So for those are from the chemistry, you know about the catalyst, how we're going to utilize the catalyst to enhance the overall process. That one, yeah. So the thermochemicals process that I will mention, focusing more is about the pyrolysis, the co-processing, the gasification, the hydrogenalysis reaction process, and also the optimization and how we going to do the optimization. So this about the objective of the courses. First is the concept of the biomass. So what is the biomass? So So what is the benefit of the biomass? Anyone can tell me?
Input cost is good.
Input cost is low. Why is low? Why?
Abundantly available.
Okay, yeah, abundantly available. Okay, this one thing. And
Less green oxygen.
okay, then yeah, Jameson, then
It is carbon neutral resource of energy.
carbon neutral energy. Okay, what else?
It is usually thrown out as waste.
Usually,
It is conventionally thrown out as waste.
yeah, the waste. One thing is what? Another thing, you mix up. No need to import from anywhere, because we can use any biomass that available locally. That is a very significant thing. Because the resources is very important. We need to utilize the resources that are available in that region. That is one thing. No need to import the thing. Yeah, what you mentioned here is correct. All are correct. So another thing is you no need to import any raw material or the resources. You can utilize any type of the biomass waste from your region. And building the capacities in the applications, not only the process then, but how we going to utilize it through the various thermal chemicals process, like the catalytic thermochemical process. Catalytic maybe utilizing the catalyst in the process. Co-processing, for example, in your agricultural plant, you have a few types of the biomass waste. How we going to mix up together for the co-processing. So the hydrothermals, some of the biomass are in the wet form. So I think all of you know, dry process is very costly, expensive, correct? Not the dry process. So we can use the hydrothermal. Hydrothermal is what? In the wet form. No need dry process. So what is the benefit of using the hydrothermal process? Then the gasification. So for the pyrolysis process, basically pyrolysis and gasification is almost similar, not the same, but almost similar. So for the pyrolysis process, basically we focus more on what? Bio oil, or maybe the solid product. But the gasification, we focus more on the gas product. Yeah, that's the only difference, and also the overall reaction temperatures are different, and also pyrolysis. And also the lastly, we need to explore the practical problems and their solutions. What is their practical problem that facing? Because just now all of you mentioned some of the practical problems that are facing currently. Throughout the case study, I will show you a few case study about the biomass waste to bioenergy. So this is our objective. So any questions? So this is the course content throughout this whole week. So today is the instruction about the biomass. So I will introduce about the solid biofuel production from the waste biomass and using the ultrasonic reactions and the catalytic thermochemical process and also the biomass process. Yeah. Co-processing of the biomass and also the plastic waste. So how we going to convert the plastic waste for the hydrogen production? And we have conversion from the waste material into the jet fuel. So throughout the courses, I also will share my experience. So how I'm doing the research from the very beginning, from the liquid fuel, the biofuel, biodiesel to the jet fuel research. Why I do so? Then we are using the advanced technology, which the microwave co-pyrolysis. So this one, the Dr. Remira will discuss more about that, because her expertise is about the microwave. And also the co-hydrothermal that I mentioned to you. It's the wet biomass. So what we going to do it? We can use we can do the pre-treatment by using the hydrothermal process. So I'm also our group also using the microalgae biomass as well. Because why microalgae? Currently, the microalgae are used for what? Pharmaceutical application, correct? Not? So they culture the microalgae because of the protein content. And also other compound which I don't know because I'm an engineer. They extract the pharmaceutical compound, but to waste biomass. What we going to do with on it? We can utilize to convert it into the biofuel and other value-added products. So also discuss about the biomass classifications or the biomass through the fast pyrolysis process. And lastly, we also will discuss about the challenges and also the future perspective of the biomass and bioenergy and biofuel. This is the cost that will be covered for cost content will cover for this process. So any question, any suggestion, any discussion? If not, now I would like to start the lectures for today. Which you know, why I show you this one? The global energy consumption versus the industrial revolutions. Because for every time of the industrial revolution, the energy train will be changed. Later I show you. The first, you see the first industrial revolution happened during 1784. 1784 which here, nothing. So everything moves into the mechanical production. We have the railroads and also the steam power. From that time, you see the biomass energy is increasing. Previously, there are no any energy because we are burning the wood or whatever only. After the first industrial revolution, here is the biomass. The biomass energy is increasing. After 100 years later, the second industrial revolution happened during the 1870, which everything moved into the what? The mass production. We have the electric power already during that time, and also we have the assembly line. You see, start from that time, 1870. You see, the demand of the coal starting already, right now. You see, this is the second industrial revolution. The energy train is changing, totally changing. It's changing until the third industrial revolution. You see, here the coal is increasing, the demand of coal is increasing until what? Until the third industrial revolution, which happened in 1970, which everything changed to automation. We have the electronic products, correct not? Electric products and the computers start to introduce during that time. Starting from that time, you see, the demand of the energy train changing again. Well, for previously, we just utilizing about the biomass, the wood or whatever. Then starting to use the coal. And during the 1970s, we are using what? Cover the what? Oil and gas. The oil and natural gas. The demand of the oil and natural gas is increasing until today. So the total fossil fuel, which from the coal, from the natural gas, and from the oil, account 85% of the total energy consumption. Currently, after year 2010, the fourth industrial revolution is happened. Everything changed to what? The AI, artificial intelligence, changed to what? We have the big data, robotics, and more to come, which I don't know what will come. I know more and more will come. So during that time, we need even more energy consumption, correct not? The overall energy train will be changed. Change to what? I don't know, because currently the fuel cells, the hydrogen, it's coming, correct not? Yeah, that's the thing. So we need to think, what is the solution for the energy consumption and also the emissions? So that's why this figure, this figure, no one is discussing about that one, They are the very closely correlation with the industrial revolutions. We need to think, currently happen. See, for example, like many AI or I don't know, I don't want to name any company. Later they capture my video because that's why I just worry put it online. If offline I can take how many things, Because if I name any company and they go, hey, no, I didn't do so, because all the companies they want their what company vision in line with the SDG and green energy, correct not? Then okay. Then you see, more and more will come go to the automation or whatever. The energy demand will be increasing. They need the energy consumption for that. the data centers, right now, the data center. About the AI, the automated control in the remote area. Then how we going to have the energy consumption for all these things? This is what we need to think especially in the remote area. That's the thing. Then we need to think out what's the solution. Because we all are engineers and also scientists. We need to find the solutions. The solution for me, the solution is not the energy saving. Energy saving is one of the solutions. Energy saving means, for example, what? Aircon. We want to maintain at maybe 22 to 24 degrees C. You say you want to have the saving, or you want to increase it to 25 for me. As an engineer, that is not a solution, because people want to have their very comfortable life and become more and more easier and comfortable in the future, right? Not? So energy saving is not the solution. Mean for me, yes, I support the energy saving. Don't twist my word. I say I don't support the energy saving. Yes, for me I support the energy saving, but as an engineer or scientist, we need to find the way that people still can enjoy the life while reducing the energy input, or reducing the emission, or reducing the waste. This is what, as an engineer, we need to think of. Yeah, that's the thing. So I just very worried. That's why people keep saying, oh, this one, he don't support the energy saving. That's the thing. Now very dangerous. Yeah. So you see, this one is just an instruction. I think all of you know already. This all data can be get easily from the BP statistics, or from the energy consumption website, or any website which I mentioned. 85% of the total energy consumption come from the fossil fuel, which is come from the oil, coal, natural gas. Then the energy demand is increasing year by year. Why? Because due to the increasing of the population. Second thing is due to the more and more comfortable lifestyle, and more gadget, and also the AI things coming right now, because make it the energy consumption slowly will increase. Slowly will increase. With the increasing of the energy consumption, will bring one drawback, which is the emission. You see, from the 17th century, 1800, the emission is less than, is almost zero. But until today, year 2000, the total CO2 emission is reaching 10 billion metric tons per year. This will cause a very harmful impact to our environment. Will cause the global warming, and also the acid rain, which I think all of you already know this one. So it will cause a very serious environmental problem. So there is nothing wrong. We just using the energy causes like what you all mentioned. Energy causes relatively low price, right? Low price. Why? But this is the problem. The emissions, the pollution. So out of this emission, people will say our plantations or naturals, we need the CO2. CO2, but currently the statistics show that the naturals only can absorb half of the total CO2. So it will cause what? Global warming, cause the temperature, the global temperature increase year by year. So we need to think of one of the movement toward the generating low renewable energy. Low carbon renewable energy to help to reduce the greenhouse gas emissions. So what is the solution? For me, as an engineer and scientist, there are two ways to reduce it. One is through the energy efficiency method. What is the energy efficiency? What is energy efficiency? You see, your lighting system. What is the lighting system you are using? I don't know if it's an LED light or fluorescent. Okay. 50 or 60 years ago, I think most of you are not experienced. We use the incandescent light bulb. You know, right? Incandescent light bulb, light bulb, the yellow one. Yes.
Tungsten bulb.
Tungsten bulb. Yeah. Incandescent light bulb. No problem to using that. But 80% of the energy using the tungsten or incandescent light bulb convert into the what? Heat instead of the Then after that we replace with the fluorescent light. So the overall energy consumption need for the fluorescent light is reduced significantly, reduced 100%, 80%. use 80%, but the thing is what? The light intensity is increasing. It is increasing. Light intensity. Currently, we have the what? LED light bulb. Then the overall cost for LED light bulb also very relatively low. Of course, it's higher than the fluorescent light bulbs, but the overall light is relatively low. Then we can use back the same system, right now. Same system. I mean, for the LED light bulb. So we just replace the LED light bulb. Replace the fluorescent with the LED light bulb. The overall energy efficiency can be reduced, and the LED light bulb normally they have the highest light intensity. For example, you want to install the 4 fluorescent light, maybe you can install 2 only with the even higher light intensity. So this is the energy efficiency methods. So we no need to sacrifice of our comfort lifestyle. For example, off one light or whatever, so that we reduce the light intensity, and that is the way. And then another way is what? The power plant. Power plant. If you are able to find the method to increase maybe 2% of the efficiency of the power plant, I mean the overall 2% of the energy can be reduced significantly, then the greenhouse gas can be reduced. So this is what we call the energy efficiency. Energy efficiency method can be used in every sectors, the building sectors, the power sector, in any area, the lighting system or any sector. So energy efficiency is one of the methods. The second method is about the renewable energy. We can using the renewable energies like the solar, the biomass, which the biomass energy is what we want to discuss in this course. In this course, I only will focus on the biomass energy. So this one is energy, the hydro energy. So this all energy, renewable energy or sustainable energy can be reduced the greenhouse gas emission while you can produce things the energies to cater the energy demand that needed to the current world. So, but how we going to utilize these all energies? This is the thing that we need to think of. So, how we going to utilize the wind? For example, the hydro energy. When we want to build the hydrogen dam, the whole areas will be sacrificed to build the dam. So, but how we going to minimize the effect? This is what the engineers are